Hello, ladies and gentlemen. Good morning to you. We are working on our very first section in the unit circle, which is going to consist of 9 worksheets. Section 1, we're going to talk about angles in standard position, and we're going to start with degrees and work our way around. So, at this point, how much are we going to be writing down for our notes? We're writing down about that much stuff right there. We'll have an example, and then another paragraph, and an example. And hopefully, after doing that, you will know how to do everything that's in your worksheet. So, let's zoom in a little bit. So when I look at this, what I want you to write down, you're going to be writing all this stuff down, and then I have this drawing for you. What's important about this drawing that you need to have, because some of you will not be able to put 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75, and so on. What I would recommend that you have are these axes. Draw this line and this line, the vertical and the horizontal. Draw the 0 degrees, the 360 degrees, the 90 degrees, the 180 degrees, the 270 degrees, and the quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. I'd recommend you write all this down, but in this picture, have just the axes, degrees. If you want to add all these other little ones, you're welcome to do so. But also don't forget there's quadrant labels here as well to write down. What I want the substitute teacher to do is to press the enter button now to pause. Unpausing the video, here we go. What we're going to learn in this whole section is on angles. And so I have 2 examples here, a green angle and a red angle. Let me open that up just a little bit. This green angle is a positive angle because it opens in the counterclockwise fashion. If it were to open and go in the clockwise fashion, that would be a negative angle. So positive angles go around this way, whereas negative angles go the other direction. So with that being said, angles that are in standard position have an initial ray on the positive x-axis. What that means is that all angles are going to start right here on this x-axis, on the positive x-axis. Everything we do in this chapter is going to be in standard position, starting here and then going whichever direction that we tell you to do, or how far the angle would be. Positive angles go counterclockwise from the initial ray, and negative angles measure clockwise from the initial ray. All angles are going to start at this place. And so, for example, I have 60 and negative 60, but easily I could tell that 120 degrees positively would put me right about here. And that would put me in quadrant 2. Whereas a negative 120 degrees would put me right here in quadrant 3. That's important. That's what we're going to do today. We're going to draw angles in standard position, and what we're going to also do is name the quadrants that the angle is going to lie in. So, that's kind of our first big step, is knowing this, committing it to memory. The second thing that we're going to write down today is called coterminal angles. Let me make sure this is big enough. Right there is about the biggest I can get it and fitting it on the screen. Let's take a break right about here so you can write down what you see there. You don't need to write down the example that I'm covering up with my hand. Substitute teacher, please pause the video by pressing enter now. Coming back to you. Coterminal angles are angles that have the same terminal ray, or they end at the same spot. These, for example, 300 degrees is coterminal with negative 60 degrees and 660 degrees. Let me go back to this picture. Here's 300 degrees. I'm going to use my pen as the example. Let's say that this is 300 degrees. Why is it 300 degrees? Because here we go around 90, 180, 270 plus 30 more degrees is 300 degrees. That's the same angle. It's coterminal with negative 60 because they end in the same spot. They are equivalent to each other. What else do we have? We have positive 660. We can go around, not just once, we can go around again and go 360 and just add another 300 degrees to that. And we will get to right there, which is also coterminal with it. This is considered, let me circle it, a positive coterminal angle. This is considered a negative coterminal angle. Your textbook, your worksheet today is going to ask you to find a positive coterminal angle and a negative coterminal angle. So what I had you write down was that angles that are greater than 360, meaning more than one revolution, it may be helpful to add or subtract a revolution 360 to find what it's coterminal with. Keep that in mind. If I ask you to find some coterminal angles, you sometimes add 360, sometimes you subtract 360. And then if it is greater than 360, you might need to add more than one revolution. You might have to add 2 revolutions to figure it out. Let me give you some examples that we can do together. This one you do not have to write down if you do not want to. You can do it in your homework. Now I've added 3 letters here because some of your questions are going to ask you to do one thing and some of your questions are going to ask you to do another. And I thought to myself, if I ask these 3 questions about this problem, hopefully my students will be able to do all the homework. So let's show you how it works. This is number 6. These directions may not match entirely with what's in your worksheet on worksheet 6, but at least 1 or 2 of these will. So let's do it. Draw each angle in standard position. I'm going to draw my final answer. I'm going to show you how I get it. This is negative 400 degrees. Positive angles go this way. Negative angles go this way. So if I start here, let me switch to blue. If I start here and I work my way around, that in that direction is negative 360 degrees. So if I'm thinking about, well, that's negative 360 degrees, how many more degrees do I have to go? And if I have to go that much, what would that look like? Okay, I should know what 45 degrees looks like. I have to go an additional 40 degrees. Oh no, that's not what I wanted to do. Is equal to. This is coterminal with this, isn't it? Doesn't negative 360 and negative 40 degrees, aren't those a negative coterminal angle? Well, where does that look like? That looks like 40 degrees is right about there. So, my final answer is this thing that's green. For part A, draw each angle in standard position. This is negative 400 degrees. This is my part A answer. Do you have to show the direction that you're going in? No. If you simply want to go like this and say it's going to be right about there, I'm okay with that for right now because it's just a sketch. Part B. Tell which quadrant the terminal side of the given angle will lie in. So for part B, I'm hoping you know what we wrote down earlier in that picture was that we start off in this upper right quadrant. That's 1. Then we go counterclockwise, just like the angles that get bigger, 90, then 180. Then we go down here, quadrant 3, and then this is in which quadrant? Quadrant 4. We usually use Roman numerals to describe the quadrants. If you just put 4, that is correct as well. But normally, to be fancy, I use Roman numerals as well. Part C. Find 2 angles, 1 positive and 1 negative that are coterminal with a given angle. Part C. Well, I already figured out that negative 400, if I add 360 degrees to it, what I get is that I get negative 40 degrees left over. Feel free to double check me with that on the calculator. But I'm pretty sure I'm right. And if that negative 40 degrees is a negative coterminal angle, I need to get to a positive coterminal angle. Well, in order to get to a positive coterminal angle, I'm going to have to do something to this. I'm going to have to add a revolution to it. 1 revolution in degrees is 360 degrees. Let's add that to there. On my calculator, I can do 360 minus 40, and I'm going to get that as 320 degrees. Here is a positive coterminal angle. Here is a negative one. We've answered 3 questions. English math guy. We drew the angle in standard position. We could tell what quadrant it is in after we figured out, after taking off that extra revolution, where it is. And then we found an angle, a positive one, a negative one, that's coterminal with that. I'm hoping that if you understand how to do this, you'll be able to answer like the first 12 questions or so on the worksheet. So here's what I want you to do. To check for understanding, to make sure you know what you're doing. I'm going to have the substitute teacher pause in just a second, but I want you to ask your partner, the person you're sitting next to, do they understand? Do you need help explaining any part A, part B, part C? If you need help, it's a good time for you to discuss this with your neighbor. So, substitute teacher, pause right now. I'm hoping they have just finished discussing the problem. So next, we need to talk about reference angles. Reference angles are the last thing that we need to cover. What I want students to write down is just this last sentence in their notes. You don't need to write down this stuff that's over here. That's an example. We'll get to that in just a little bit. So why don't we go ahead and pause real quick for the students to do this. Press enter now. Coming back to you live. What are reference angles? They are the positive acute angles. It doesn't matter if the original question is negative, the reference angle will always be a positive number. It will always be acute. It will always be less than 90 degrees. They are the angles formed by the terminal side and the x-axis. That's important. If you don't know what it is, it's made by drawing it to the x-axis. And it is represented by theta prime. This little apostrophe is something that we call theta prime. This is a variable theta. It's what we use in higher level mathematics when we have an angle that we're trying to work with. Theta. Let me spell that for you since you probably have never used theta before. Theta. Theta. That's theta prime. Theta prime is the reference angle of theta. There you go. So let's do an example. This will be our last example. Hopefully it'll make sense to you as we go through it. And we're going to be finding a reference angle, and we'll talk about theta prime. Here's the directions. You could do this in your worksheet if you would like. You do not have to have it in your notes unless you want to. Number 23, negative 237 degrees. Draw each angle in standard position. Then draw a right triangle using the terminal side of the angle and the x-axis as the two sides. Show the reference angle, theta prime, in your diagram. Find the measure of theta. So negative 237 degrees. If I start here and I work my way around and I go downward because it's a negative angle, let's just count. This is 0 degrees, negative 90, negative 180, and if I keep going, I get to negative 270, too far. So if I'm thinking about this, this is pretty darn close to what I'm looking for right here. This is my angle theta. It's negative 237 degrees. Draw each angle in standard position. This blue ray is the answer to call this part A. Part B. Then draw a right triangle using the terminal side of the angle and the x-axis as the two sides. What does that mean? That means you take this and you drop down a straight line to form a triangle to the x-axis. And what it's asking you to find is it's asking you to find for part C theta prime. This is theta prime, the reference angle. The reference angle is what's the angle made by your terminal ray and the x-axis. So what you're going to really have to do on the problems that look like 23 is you're going to have to really keep in mind the 180 degree mark and the 360 degree mark. This 237 went past the 180 degrees, didn't it? And it could be even a negative one at that. How much further past the 180 did we go? As you think about that, think about the math that you could do to figure out how much further did you go than the 180. Did you go 57 degrees past? Well, how come you're not using a negative here? Because reference angles are always positive. I want to know what the positive distance is from the x-axis up. I don't care how close you are to that y-axis. How far is it to the x-axis? That's the reference angle. So guess what? The answer to part C is 57 degrees. When you do your problems, sometimes your angles will start off at a negative, sometimes your angles will start off at a positive, and you basically just draw it from there. Now, I didn't show you this, but if I were to start off with something that looks like this, and the angle theta starts off at, let's say, 45 degrees, it is possible for theta prime to be 45 degrees as well. The only time you will ever get a theta and a theta prime that are the same is if both of these are quadrant 1 acute angles. Everything else, your theta and your theta primes will be two different numbers, just so you're aware. But the theta primes will always be positive and they will always be acute or less than 90 degrees. So with that being said, I think this is enough information for you to be able to do the worksheet. We are going to end our notes right there. You have some time to do your work, and then I will catch you in the next video.